Hey, hello and welcome back. Good afternoon. After that sizable lunch break, I hope we're all back and ready to continue. I took a quick look at the CTFD instance, and I can see a lot of you have submitted flags for the enumeration to exercise. So that's great to see. Ranging from before the lunch break till a couple of minutes ago. So that's awesome. Okay, yeah. So unless there are any questions, and if there are, just please drop them on Teams. But I think we can ready to move on. Right. So before lunch break, we were enumerating the non-living aspects of Victim Cloud. And now that we have uncovered a whole bunch of subdomains and a whole bunch of applications, we're essentially going to be investigating all of those subdomains and apps and servers and services. But before we get to that, we're going to do a little brief excursion into enumerating the people, right? So looking for usernames, maybe looking for passwords as well. We're just going to take a brief look. We're going to discuss some techniques that we can use to possibly enumerate some usernames. So obviously, once we get to an interesting web app, an interesting maybe internal application that's exposed, we're going to have to want to log in. And obviously for that, we're going to need a username and probably a password. So where can we gather usernames from? Well, there are multiple ways we can do this. We're going to be looking at things like Office documents and PDFs and just documents containing metadata, and see if we can find anything like that, because that sometimes can reveal a lot of information about the internal username schemes that a company might be using. We'll also be looking at some APIs provided by the cloud vendors themselves, which can be used for enumeration purposes. Those are applicable to pretty much any situation whatsoever. But in certain cases, we might not even have to do all of this work because sometimes usernames are essentially considered public information or not sensitive whatsoever. And it really depends what kind of application are you dealing with. For example, if you think of Gmail, the way you log into Gmail is with your email address. That's your username. And that makes perfect sense. But if you are a bank, for example, if you are a financial institution and you've got some internal web apps, some internal applications that you use, for example, to troubleshoot SWIFT payments or SEPA payments and so on, the people managing or logging into those applications, you don't need to have an easily rememberable username and passwords. You can be a little bit more creative and essentially come up with a username that isn't easily guessable, therefore making the attacker's job much more difficult. So it really depends on what you're dealing with. Again, if you're dealing with something like something public facing, oftentimes you'll find that the usernames are not very secretive at all. Again, really depends on the context. But once we have an idea of the kind of usernames that we might find in the application that we're going to be targeting, we need to somehow acquire a password. So we can obviously try some basic brute force, essentially just guessing a password for a particular account, or we can flip the approach on its head and employ something called password spraying. But before we get to that, let's talk a little bit about usernames. So most companies, most organizations have some kind of pattern that they follow, right? So for example, if you've gotten an email from me regarding this training, actually, I think that came from cloud@notsosecure, not Martin@notsosecure, but my email address is martin@notsosecure.com, because we can get by just by using our first names. But obviously, a larger corporation, that would not be feasible. So that a larger corporation might have to use a different format, a different schema, a different pattern to essentially construct email addresses that don't have collisions with one another. So, you don't end up with, Martin 37 at Not So Secure because there are other 36 Martins working at that company. That would be a bit strange. So better to choose a different format. So usually it's something like first name, full stop last name, or maybe last name, full stop first name, maybe a last name and like a character from your first name. There's a couple of formats that get used a lot. So once you determine that, we would also need to have a couple of good guesses when it comes to actual names of people. So getting a list of people that work at a particular company, it's actually quite easy when you think about it, because pretty much all you have to do is just go on LinkedIn. A lot of people have profiles on LinkedIn. I think many of us do. As such, we publish information about where we work and where we used to work. So that information is fairly easily scrapable off of LinkedIn.com. You might even find like offline databases for sale where someone has crawled LinkedIn.com for a long time and essentially acquired a lot of data from it. And they're just selling it as like a searchable database offline, because obviously LinkedIn is going to rate limit you online. So that was some time ago, there was a suspected breach of LinkedIn, but it turned out that it wasn't a breach. It was literally just a group of people that written a script that essentially crawled all over LinkedIn.com and scraped a lot of information, and they've saved it locally, and they were essentially distributing a database for a couple $100 that you can instantaneously search for lots of information, like people that work at a specific company and so on. So that could be really useful to attackers trying to quickly get their hands on a list of employees of a company, or at least a publicly accessible list of employees of a particular company. Okay, so what is the attack surface when we look at cloud? Well, there are a couple of services, a couple of cloud native services, which might end up actually allowing you to enumerate valid usernames. So if you've ever had a pen test report in your hand regarding some kind of internal application, maybe, there's a very good chance that it listed something called verbose error messages. So what does that mean? Typically, that means that, for example, you've got a login form, and depending on if you put in a correct username but incorrect password, it's going to give you a different error message as opposed to you providing an incorrect username and an incorrect password. Right? So essentially, it's trying to be user friendly by saying, yeah, that username exists, but you got the password wrong, as opposed to not being very user friendly and just saying you've done something wrong. If you do leak out that information that, yes, this username is correct, but the password isn't, then an attacker can use that facility to essentially mount a username enumeration attack. And if a pen tester does this, they're probably going to put it in the report as verbose error messages / username enumeration. And this really depends on your policy. Like, do you consider usernames to be public or not? Do you need to protect usernames, or do you not care? Are you risk accepting things? And that's completely fine as long as you get to make that choice. But it turns out that in the cloud, you don't always get to make that choice. And sometimes that choice is made on your behalf. For example, with AWS, when you are setting up policies, for example, the update assume role policy, essentially when you are dealing with role assumption policies, when you're creating the policy, sometimes when you are specifying the target role, AWS will look up that role. And if it exists, it's going to allow you to save. everything. And if it doesn't, it's going to give you an error message. And you can essentially use that to facilitate like an enumeration of a target account and the roles within it. Similar thing can be achieved with AWS Cognito, where through the forgotten password functionality, you essentially would be able to keep specifying, for example, email addresses. And Cognito would be telling you, yes, that email address exists. We have sent you an email with a link to reset your password. Or it would say, no, this email address is not in our database, sorry. And again, that can be used to facilitate an enumeration attack or just an enumeration activity trying to enumerate email addresses of existing users or usernames. And so those were two examples from the AWS world. And just so we're not that one-sided, let's take a look at Azure. So with Azure, there's an interesting functionality within the login form that Microsoft uses. As you can see, we are dealing with the login.microsoftonline.com website, which essentially is just a login form. And when you're filling it out, it first asks you for your username. And essentially it takes that username and it does some lookups on it. And it tries to determine, okay, is this a Microsoft user? Is this a Microsoft account? Or is this some internal account that from a company that uses our products? Or what is going on? And based on that, it determines what to do with you. Maybe the best thing would be to just show you a really quick example. So let me go back to my browser here. I'll go to login.microsoft.online.com. And when I do, it's going to load up this login form. And depending on what I put in, it's going to behave differently, right? So I could say martin@linkedin.cloud. And it might say this username is incorrect. Make sure you did it properly. So it's essentially letting me know that this username, we don't know this user. But if it was something like this, Klarna.com is our parent company, you would notice a completely different behavior. That is me being redirected to the organizational sign-in page. I'm sure a lot of us have seen this before. Essentially, this is how a federated domain works, or a federated setup works. So at that point, it doesn't really matter what my username is, right? As long as, because the system might not be checking that. The system will be looking at the domain here, right? So this email address probably doesn't exist, but regardless, I will still be redirected to my internal organizational sign-up page, or sign-in page rather. Right, so this form clearly has a lot of functionality hidden inside that determines what happens based on several factors. The main thing is looking at your username and looking at the domain and trying to determine if it is managed by Microsoft. There are a couple of options. It can be directly managed, for example, by Azure AD, in which case Azure has all the information to determine whether your username is valid and whether your password matches their records. Or it can be federated, in which case it doesn't not have the answers. Or it can be completely unknown, in which case you can't log in. So there are different scenarios. And some of those we can use to our advantage as attackers in our attempt to be enumerating users of a particular domain. So this attack is only going to work if the target domain is directly managed by AAD. And if it is, then we can essentially be submitting lots and lots of usernames to another endpoint from this login Microsoft Online website and looking at the results. So how bad is this? How vulnerable is this? Well, Microsoft obviously knows that this could be a problem. So what they do is they have a rate limiting system in place, which serves as kind of a compromise between user experience and user friendliness, where the login form is quite clever and it tells you, no, you made a typo in your username, versus your username is correct, but the password is wrong. So it can be quite friendly at the beginning, but as soon as you start to abuse the form, the functionality of the form, after about 100 requests from your IP address, it gets upset. It gets upset with you. And what it's going to do is it's going to start to rate limit you. And it does so by just providing by providing essentially random results to you regarding if the username exists or if it doesn't exist. So it's essentially, if you're doing this as an attacker in a script, it's after about 100 requests, after about 100 requests go through, it's going to taint the data that you have, right? Because it's just going to start outputting random, 50-50 random data back to you before it cuts you off completely. So there's an interesting rate limiting mechanism in place on this Microsoft login form. But nevertheless, if we are careful and if we're smart, we can enumerate a little bit at least. We can at least enumerate about 100 requests, about 100 usernames, candidates against a particular domain before we get rate limited. But we have to make our guesses wisely, right? Because we do not get like an unlimited amount. I mean, we do, but we would have to do this very slowly, essentially. So both of these endpoints are implemented in a tool called enum Azure AD users. That's also on your VM, and you can use it to essentially look things up. We're going to do that in a minute, but before we get to that, I'd like to show you what you can do if, for example, your target domain, your victim are not managed by Microsoft Azure AD. So I did mention that you can also leverage metadata from documents. Lots of documents contain metadata about, for example, who created the file, who modified it the last, how many times it's been saved, how many minutes it has been opened for. Like, especially Microsoft Office documents really do keep hold of a lot of metadata like that. Unless you strip away that metadata, it will be carried inside of the file. So essentially, if you're targeting like a small website that maybe has some PDFs or Word documents or Excel spreadsheets on the website for download, for example, you can do that, and you can essentially rifle through those documents and try to find interesting information about the user accounts within that particular company. You can do so manually, for example, with the use of EXIF tool. Again, EXIF is typically something we associate with JPEGs, but the EXIF tool is quite clever, and it can also process Word documents, spreadsheets, PDFs, and so on. So you can do it manually, or you can use an automated solution. In this case, where we are giving a shout out to a project called Foca. I'm going to quickly show you because I like the grumpy little animal as the logo. So yeah, you can essentially use a tool like this, which is capable of processing a bunch of different files. If I can find that quickly here, yeah, it's capable of processing files like Microsoft Office file formats, OpenOffice PDF files, some Adobe files, SVG files, and so on and so on and so on. And obviously extract interesting information from those files. All right, so do we have any more choices? And the answer is yeah, absolutely. So when you look at, for example, code repositories, source code repositories are typically a goldmine of sensitive information. because it is very easy to make a mistake and accidentally commit something that you didn't mean to. But once you push it out to the world, to the master server, to the world, it is very difficult to take that back. Obviously, you can realize what you've done and remove the information again, commit the deletion of the sensitive information and push that commit out as well. However, it's in Git's nature, not just Git, but Subversion or any other version control system. It's in its own nature to essentially maintain really good historical record of all different changes. So even if you commit a file and then you realize, oh no, I shouldn't have done that, and then you remove it afterwards, it is still going to be in the commit history of that particular project. And that's what tools like Trufflehog, or in this case, ShushGit, look for. That's the fact that they leverage. Essentially, you can point these tools, Trufflehog, ShushGit, many other tools, you can point them towards a code repository, for example, on GitHub, GitLib, Atlassian, Bitbucket, anywhere really. And it is capable of going through the commit history and trying to find out or trying to locate interesting information that might not be there still. It probably was removed, but it is contained in the version history. So things that have a predefined format that it's easy to identify and look for example, AWS access keys, secret keys, usernames, passwords, things that look encrypted or encoded, maybe log files, SQLite database files, and so on. Just many, many different things can be found automatically like this. If you're very lucky, maybe just Googling the right sequence of keywords could lead you towards getting your hands on some credentials. In this case, we're essentially searching through S3 buckets on Google, and we are searching for the phrase AWS_secret, which tends to be around, the value really says, the name of the value really says it all. It tends to be in close proximity to things like access tokens, access key IDs, secret access keys for AWS. But I would say if you do a search like this and you get some hits on Google, if Google has had time to index whatever you're looking for, chances are you are not the first person seeing these results. So maybe this won't be, these credentials that you can uncover, maybe they're no longer valid, but it's definitely worth a shot. I mean, it's not much effort to run a single search like this. Because I've already mentioned Git repositories. Some code repositories also have internal search functionality that you can leverage. For example, on GitHub, we can search through the code bases there, and we can search for all sorts of different keywords. For example, this one, default endpoints protocol. So if I go on GitHub and I just search for this keyword right here, it turns out that this default endpoints protocol keyword is, or tends to be, in close proximity to credentials. So we get, we don't get much here, but if we look at the second result right here, we actually get default endpoints protocol equals something, and then it says account name, account key, there's another account and account key. There's already getting lots of information for very, very little effort. And we've got some 64,000 code repository results, right? So that's quite a lot. And chances are that, even if 1% of all of this was valid, that's still, a lot, a lot of credentials. Honestly, even if just one set of credentials out of all of this were still active and could be used for malicious purposes, even that is pretty bad. Okay, so that brings us to the next exercise, in which we're essentially going to be looking at victim.cloud and trying to determine whether they have some integration with AAD And if they do, if we can enumerate some usernames from this domain then. So let's take a look. All right, so victim.cloud, let's essentially think back to the slides. A couple slides ago, I showed you these two endpoints from the Microsoft login form. The first endpoint essentially determines the relationship between Microsoft and the target domain. And if the target domain is managed directly by AAD, then we might be able to do some username enumeration. So let's first try to determine if victim or cloud have a relationship with Microsoft. So to do that, I'm running a curl command here, and I'm querying this login form, this particular endpoint called getUserRealm, and I'm feeding it this email address here. So test@victim.cloud. And what I'm getting back is a bit of XML, and apparently victim.cloud is directly managed. How handy and totally surprising. If I were to change that, for example, to claranet.com, I've shown you in that quick demo, you'll notice that it now says federated. So the relationship is different, and in this case, we wouldn't be able to do much. The same thing if we were using a domain that doesn't have a relationship with AAD whatsoever. Right? So if I put my own domain there and I know I'm not using any Microsoft services on that domain, it's going to say unknown. So there's no known relationship between this domain and Microsoft Azure. Therefore, not much enumeration will be. It will not be possible for much enumeration, really. But let's think back to the victim or cloud domain. So apparently, victim or cloud is directly managed. So in theory, we should be able to start guessing usernames against Azure AD, because Azure AD is directly managing this domain. So Azure AD also holds all the answers and all the data so they can answer any questions that we might have. So let's take a look. So I'm going to run another curl command, again, from the slides, the second one. And I'm hitting this get credential type endpoint here. And I'm sending a post request there. And I'm essentially just sending over the username, test@victim.cloud. And what I'm getting back is the digit 1, or at least it's part of the JSON result. Now, this endpoint is a little bit funny to work with, because if it says 1, that means there was a problem. That means that username does not exist. If it gives you a 0, that means, yes, that username is valid and exists within the environment. So yeah, again, it's slightly counterintuitive, but once again, this endpoint was not meant for hackers to enumerate off of. This is meant for some internal workings of the login form. So again, it's not meant for us to be looking at the results like this. So that's why it isn't very intuitive. But we can keep continuing with this enumeration. So instead of test@victim.cloud, we could say something like Martin. That's a 1 as well. Maybe something like Bob. And spoiler alert, that gives us a 0. So this account probably exists. Now, doing things by hand is kind of prone to errors, and also doing guesswork like this isn't great. So what we can do instead is we can get a list of popular names and grab the most popular names out of that list and run this however many times we choose to and see what happens. So we do provide you with a list of popular names. Let's check it out. So we've got a file containing names like John, William, Charles, Frank, Bob, Joe, and so on. But there's quite a few. It's like 250,000 names in that file. So That's a bit too much. That's a little bit too much. This would definitely put us over the limit of essentially being applied. Um, sorry, this would put us over the rate limiting limit, and we could definitely run through this entire file, but we would only get about 100 good results before the data that we would be getting back would essentially just become nonsense. So we need to be very careful on how many entries we're actually going to be using from this file. So I'm going to grab the top 30. So I'm using the head command. I'm telling it to use 30 lines from this file. So it prints it out, and it also saves it to a file called popularnameslist.txt. Okay, so I can actually check that out as well. Yeah, that's the file. Does it really have 30 lines? Yes, it does. Okay, brilliant. So now I can use the command I've shown you on the slides as well, called enum Azure AD users. Again, if I run it without any arguments, it's going to give me essentially a quick help section saying you need to provide the domain name and a text file full of potential usernames. So let's do just that. So I'll say victim.cloud is the domain, and popular names list, which I just created, is the text file containing all the guesses for usernames. So let's run this. And you can see that it first determines the relationship of the domain with Microsoft Azure, and then it tries all these usernames based on the text file I provided. And none of these have been found. However, we did find Bob as an account that does exist. We also have a account called Kevin. And finally, we have an account called Alice. So we were quite lucky. We managed to find 3 accounts that probably exist. Obviously, we don't have the passwords for those accounts just yet, but this is a good start. Right? So essentially, we've used a cloud API exposed by Azure itself, or Microsoft itself, to allow us to enumerate users within a particular subscription. Now, if you were to try this against a federated domain, it wouldn't work. It would just say, sorry, this domain is federated, meaning that Azure AD doesn't have all the answers. So, we can't enumerate it, obviously. And if you were to try against a domain that has no relationship, then it would say, sorry, we can't do that either. So it's an interesting tool. Obviously, there are some prerequisites that need to be met, like that domain has to be directly managed by AAD, which doesn't always happen. But when it does, we can actually use that fact to enumerate some usernames. So hopefully you found this interesting. Let me give you a little bit of time to catch up on this. I believe the commands are being shared with you as I'm speaking. Yeah, the commands have actually already been shared. Awesome. So feel free to follow up on this, sharing all the commands again. Yeah, that's the exercise. It's a fairly quick one. So I'm going to put 10 minutes on the clock, and then we're going to come back and we're going to continue. So good luck. All right, welcome back. So that was a relatively quick exercise, enumerating some users against Microsoft Azure AD. And again, the results that we acquired are going to come in really handy tomorrow, when we're going to be looking at Azure AD in more detail. But don't worry if you've not kept notes. Don't worry, I'll remind you tomorrow of the results. So don't worry too much about it. But yeah, this is going to be we're going to essentially build on top of this enumeration tomorrow. But for now, let me wrap up the enumeration section by saying that from the defense perspective, there isn't really much that you can do. I mean, enumeration in itself is hardly malicious. It's just, learning about a particular website or a particular organization. I mean, you can guard yourself by risk accepting it, essentially is what I'm saying. By saying, you know what, usernames are not secret. There you go. There you go. Therefore, it's not secret. So if people learn what kind of usernames we have, then, there's not been a breach. Risk accepted. Boom. But definitely to kind of make it difficult for attackers to advance, you can deploy some defense in-depth techniques. When it comes to user accounts, MFA is probably a very good idea, because once again, even if us as attackers, even if we get our hands on a username and then we correctly identify the password for that account, should it have MFA enabled, we're not going to be able to actually log in unless we somehow circumvent that. So defense in-depth techniques usually work pretty well against scenarios like this. All right, so that wraps up the enumeration section. Again, I've shown you a couple of basic things. We're going to leave that behind in favor of looking at other cloud native services that we can actually somehow exploit and use to get a foothold in the cloud environment. But yeah, as I said before we even started the enumeration section, like enumeration is such a rich topic. Like we could talk for a day very easily just about enumeration. Don't really have the time to do that here, but I try to pinpoint some interesting ideas and concepts and tools. So hopefully you found it interesting. But now we're gonna get to the meat of it, and we're gonna be looking at Lambda functions and beanstalk deployments and so on. And we're essentially going to be looking to see if we can compromise those deployments somehow. Okay, so first things first, how do we identify that a particular application is running in cloud? Or like, how do we realize that, oh yeah, this is a Lambda function? Well, it's hard to say. From the external perspective, it looks just like any other website or as any other API. Sometimes if you look at the HTTP response headers, for example, there might be some indication as to what is the platform that is running that particular service. But from a first look, it kind of looks the same as if it was running on premise. And that's kind of the point. I mean, it's not supposed to be completely different from the outside perspective. So once we get in, the differences, however, will become very, very clear. So we'll essentially be exploring getting some basic foothold in 3 scenarios. We'll be first looking at serverless functions or function as a service deployments. Then we will be looking at relatively low-level offerings like infrastructure as a service instances. And then we'll take a look at what happens when you disable some of the built-in security controls, if you have the option to do so, again, on a fairly low-level offering like infrastructure as a service. Okay, but we're going to kick this off with serverless. We're going to kick this off with function as a service deployments. So as I've mentioned before lunch, a lot of the deployments are quite ephemeral and temporary and disposable. So getting a foothold and maintaining it can be challenging. OWASP, if you know OWASP, it's an organization that essentially does a lot of good for AppSec, and they do something called the top 10 list. And it's always focused on a particular area, for example, web applications, mobile applications, APIs, serverless. And the top 10 list essentially is the top 10 most commonly identified vulnerabilities in that particular piece of software or that particular area of software development. So to give you the TLDR, to give you the summary, for serverless, there are a couple of classes of vulnerabilities that actually have that have interesting non-standard impact. So, for example, arbitrary file read, essentially coercing the server to read files to you, can have extra impact, especially in the Lambda scenario. Again, that's something you can achieve through, for example, directory traversal or XXE. Just to give you a couple of examples here. When it comes to remote code execution, I mean, that's a pretty bad one just on its own. Never mind the cloud, that's pretty bad on its own. But yeah, if you can achieve remote code execution, for example, through server-side template injection or command injection, then you might be able to execute arbitrary commands within that Lambda function, for example, or Azure function, GCP Cloud function, and so on. Possibly trying to reach out to other resources on the network. For example, the metadata API could be an interesting target to aim for. And finally, something you've heard me say a couple of times already, server-side request forgery, or SSRF. Once again, essentially coercing the server, in this case, a Lambda function, for example, to reach out somewhere on the network, fetch the document that's there and return it to you. And whilst that may not sound too interesting, in cloud, it typically has extra impact. Again, specifically targeting, for example, the metadata APIs, as we will see in a couple of slides. Right, so those three areas are quite interesting to study when it comes to cloud and different components in cloud. So let's quickly, again, this isn't an AppSec training course. This is a cloud-based training course, but I've introduced a lot of different vulnerabilities here, different classes of vulnerabilities and so on. So I'd like to give you a quick rundown of all of this and mainly show you how these things happen so we can understand how to exploit them. And then we're going to exploit them in a real scenario. Okay, so first up, arbitrary file read, or essentially coercing a server to disclose some files to us. So this typically happens when the user can influence a particular file path on the server side, right? So for example, if you'd have a website and it's got like a downloads section, and for each file, it is keeping a track, like a counter of how many people have downloaded that particular file. So it might be something like downloaded PHP, question mark, file equals, I don't know, brochure.pdf or 2021 results.pdf or something like that. And all that script really does is it just increments some kind of counter when you click a link and then serves you the file. So nothing too special. But as a user, you are in control of the URL, right? So you can change that URL, especially the file name in the URL, to something else. And if the application isn't coded properly, then it might just allow you to do crazy things with the file name parameter. That's pretty much the basis for a path traversal or directory traversal attack. We can essentially just coerce the system to give up files that it isn't meant to. And it might sound like an old school vulnerability, and it typically is, but I've got one very recent example that I'd like to show you. So how do you test for this? Well, if you ever see like a file name parameter in a URL or in a form, for example, in a post request, you can just try to substitute the file name with something else, right? For example, on Linux, there's a file called etc passwd, which on pretty much every single Linux distribution there is, does exist. And it exists with very open permissions, essentially allowing any single user on the file on the system to read this file. We can't write to it, but we can read it. And that's usually good enough, an indication for like a proof of concept code to say, yeah, we can actually achieve a path traversal attack. Here's a POC of us reading out this standard file. So sometimes you can just specify an absolute path. That doesn't happen that often, however. At least from my experience, relative path is usually what you find, where you can essentially just substitute the file name for something like .. and so on, jumping up a couple of directories before traversing the file system again into /etc/passwd. Now, sometimes you deal with a web application firewall or some kind of intrusion detection system that flares up because this doesn't look like a very legitimate request. This doesn't look like a very legitimate file. Not at all. So sometimes you need to be a little sneaky and pull some tricks to get around some of the detection mechanisms or intrusion detection and prevention mechanisms. So what we see here on this third bullet point is actually the same thing as here. So the second and third bullet points are actually the same thing. However, the third bullet point uses something called URL encoding. And in this case, this is actually double URL encoding. Right, so we can see that the forward slashes have been replaced by this sequence of characters. So decoding this from the URL perspective, %25 is URL encoding for percentage sign. So this effectively becomes this. And then that's followed by 2F, which again is URL code for /. So as you can see, these two payloads are actually the same. It's just that expressed differently. There's just a little bit of AppSec magic in the third one, in the third bullet point here, essentially just kind of obscuring the payload a little bit. Sometimes web application developers and again, I know this firsthand because I am guilty of this. This is what I've done when I was a junior developer. Sometimes, we try to be clever and we think, okay, well, if an attacker specifies something like this, then I will sanitize that request by looking for .. and removing it from the file name or the file path, right? So therefore, if I remove these characters, then the attacker will not be able to traverse my file system. And whilst in theory that makes sense, when we look at this long payload here, this fourth bullet point right here, and if we take a look at the sequence of bytes .. and we remove it, all right, so I remove this. Here's a .. I'll remove that as well, and so on. Here's a .. remove that as well. Actually, if we do that, if we remove all of that, then we're left with nothing, .. and you can see where this is going, right? So we essentially, by trying to be clever, we've essentially taken this, what looks like just nonsense, and we have essentially weaponized it by trying to be clever. So yeah, sometimes being clever doesn't pay. So yeah, all sorts of crazy path traverser payloads here. And I promised you a recent example, because this is a fairly archaic thing. Like, this has been known for a very long time. But just to show you that, you know, mistakes happen in even a very mature software. This is a CVE write-up for the Apache web server from late last year. So this is from October last year, where there was a new version of Apache released, and they've rewritten some of the code that deals with parsing the request path, essentially. So Apache 2449, there was a vulnerability introduced in there, which essentially meant that if you submitted a request like this, you would actually be served that file. This is a vulnerability in Apache itself. This isn't a problem with the application. This is a problem with the actual web server, which is insane. That really doesn't happen very often, but it did happen in October last year. So you could, looking at the payload here, essentially what happens is, again, we can bypass the dot check by using one dot, and then the other dot, we just encode it with URL encoding. Right, so we're essentially saying dot slash slash, and so on and so on and so on, and then again reading the passwd file, and Apache just happily provides us with the passwd file, which that's crazy. So this was caught fairly early on and reported to Apache, which fixed this vulnerability. However, they've messed up, and they've messed up, and essentially what you could do is just encode it once more, right? So you would take your // payload, you would do the first round of encoding the full stop into %2e, and then you would take this value and encode it again, right? So %32, that's ASCII code for the digit 2. %65, that's a lowercase e. So essentially you end up with %2e. Right? So essentially you've just taken this value and you've encoded it again, essentially. Looking at the payload now, it's a lot less readable. It's more kind of difficult to mentally get through all of this. But this literally just means slash slash and so on. And yeah, it worked. So yeah, that was a pretty poor fix, and it essentially resulted in another vulnerable version of Apache, which then later on finally got fixed properly. But yeah, just goes to show that even archaic vulnerabilities like this sometimes do pop up again. So yeah, we should never should always be vigilant, and you should always be on the lookout for these things, even if they seem like issues which are no longer present, because you never know. We've got a very very mature project like the Apache web server. Essentially falling victim to something like this is just crazy. Okay, we've talked about all of that. Right, so that's one way of achieving arbitrary file read, essentially allowing a web server to read files. Now, next up, I've got XXE. Again, I'm not going to go into too much depth here, but essentially, XXE is an interesting attack that came to that got really popular around 2017, and it just relies on XML. So just XML documents. It turns out that the XML specification is quite complex, and in XML documents you can specify what's called an entity, which is essentially a variable. You can see that here in this 3-line XML document, we are using this XXE entity right here. And normally the XML parser would understand, okay, yeah, here's a variable. I will substitute that with the actual value of it. And it turns out that it was possible to tell the XML parser to go to some random website, read whatever is found there, and use that as the value for this variable, which is insane. Again, this has been largely remediated against by changing the default settings of a lot of XML parsers, and with legacy applications, you can usually just configure the XML reader to ignore these doc types, specifications, and external entities, and so on. But it was an interesting attack, literally just leveraging XML documents. There's nothing like malicious or special here. This is just a legitimate XML document, which tells you to go grab the value of this from a website, which in itself is not extra malicious, but it could definitely be turned into something interesting, especially in a cloud setting where we can talk to interesting places like the internal metadata API service. All right, so next up, we've got remote code execution. So remote code execution is pretty bad, as the name suggests. So if we do get to a point where we achieve remote code execution, we can start executing arbitrary commands and do all sorts of nasty things. So achieving remote code execution, I'm going to show you a couple of ways of doing that. Again, there are many. I'm just picking out a couple of interesting ones that have to do with companies that are cloud native. So here we have a problem that was in the Shopify ecosystem. So if you don't know, Shopify is a company that allows you to, that essentially acts as, it's a software as a service provider, and they allow you to spin up your own e-commerce online solution. And they are cloud native, and they're kind enough to, when they have a security issue, they usually make the initial report public after a couple of years, for example, or after some time passes. So, we as the community get to read up on it and understand what went wrong and learn from it. So in this instance, Shopify had essentially some upload functionality. You're setting up your online store. You are creating some products that you're selling. You probably want to upload some pictures of the things that you are selling. And it turns out that you could do that, obviously, in Shopify. And when you would upload an image, Shopify would process that image. So, for example, if the image was too big, it would resize it down a little bit to make it a little bit more usable on the internet. And it would also strip out some of the metadata so that you can't, so that the image doesn't store information like what kind of camera has it been captured on, and essentially longitude and latitude coordinates of like where you took the picture, because that could leak some, that could breach your privacy. So you don't want that. So Shopify take care of that by removing that metadata. But in order to do these things, they needed to process the actual image. And it turns out that the way they did it, using a vulnerable library, meant that if you uploaded a special image, right? So this screenshot here of something that is just a text file, this is actually an image, right? So this text here, these 6 lines of text, that's actually an image. It's a PostScript file, which is kind of like a PDF. And essentially this ImageMagick library can read this and render it as an image. So the problem was that there was a problem in the implementation, and essentially this yellow text on here contains a Python reverse shell code, which essentially would provide the attacker with a remote code execution vulnerability, and they would essentially have shell access to that underlying server. So yeah, that's one method of uploading like a slightly malicious image and having it be processed by a vulnerable library. Other options include, for example, server-side template injection, where if you're using something like the handlebars.js library, you might be able to push through a maliciously written template, which might result in remote code execution. And again, I'm happy to chat more about this offline or not live like this, but I think I'm not going to go into detail here because I'm just trying to give you an idea. Not really important how this happens. Just trying to give you an idea of like how many ways that you can achieve this. And finally, the interesting one, at least the one I find interesting, because server-side request forgery, or SSRF, is something that we have known about for a very long time. And it never had much use, really. If me as an attacker can talk to your website and it has an SSRF vulnerability in it, I can make it like scan the internal network to some extent. I can maybe make it request or send requests to other websites, maybe internal ones that I can't reach as an external attacker, but your application can. But all that is very circumstantial and all of that is very context dependent. But in cloud, SSRF found extra impact, like interesting impact. Because as I've been saying, we've got this thing called the metadata API. And it is only accessible internally. And it may contain some sensitive information. So if I can talk to it somehow, I might be able to extract this sensitive information out. And it turns out that that's exactly what SSRF does, right? Me as an attacker can make your application send HTTP requests, and I might be able to make it talk to the metadata API service and read the results. So yeah, that's the interesting bit, right? Maybe I can extract credentials and so on and abuse those credentials and move laterally across your estate. So that's why SSRF is interesting in cloud. Apart from that, it doesn't have that much super high impact use. It's still something that shouldn't happen, but it is most deadly in combination with the metadata APIs. And if we actually have an example here, we are talking to some application here, seems like it's written in PHP, and we're essentially just telling it to read a document. And it turns out that the application is vulnerable to SSRF because instead of the file name, we're able to specify a URL, which it then loads. And you can see that we're talking to the metadata API here, and we're essentially traversing the metadata API and pulling out some security credentials for that particular application. So, and we're actually quite successful, as we can see here. So yeah, SSRF can be very dangerous. Okay, so after that brief like AppSec intro into things, how do we put all of this together, and how do we actually, what can we even achieve with all of this? So it really depends. It really depends on what kind of provider are you with and what are you targeting. So first, let's just talk serverless. Let's only talk Lambda functions, cloud functions, and so on. We're not talking about EC2 instances right now. We're only talking about Lambda functions and Azure functions and so on. So in AWS, Lambda functions are a bit weird. A Lambda function does not have the network access to the metadata APIs. And what it does have instead is it actually has a set of AWS credentials in the environment variables, which is pretty weird because like it's like the odd one out. Everything else just talks to the metadata API over the network as usual, apart from AWS Lambda. So Lambda has slightly different attack surface to everything else. In order to compromise a Lambda function, we would somehow need to be able to dump or list the environment variables somehow. Turns out that in Linux, there are ways of doing that, and we'll actually see a demo of that in a second. But more on that, in a second. Let's talk about GCP and Azure. So both GCP Cloud Functions and Azure Functions do have the network access required to talk to metadata APIs. However, they do both require a special header to be present in all of the requests. And if you can only control the URL and not the headers, then you can't specify that extra header. Therefore, even if you're successful in exploiting SSRF, you might not be able to turn it into anything interesting because the metadata API will notice that you do not have that special header and they will refuse to talk to you. So that's why the custom headers are so important, because they offer decent protection against SSRF attacks. So to summarize, when it comes to serverless attacks, and when it comes to just SSRF or directed traversal, right? So we're not talking about remote code execution. We're only talking about SSRF or reading arbitrary files in a serverless perspective. Then AWS could be vulnerable if you can somehow get the environment variables, but GCP and Azure would not be. Because the metadata APIs are protected by design, by the way it's architectured, against SSRF. If you get something more impactful, like remote code execution, we could overcome that. But we're only talking about SSRF right now. So GCP and Azure, no dice. But with AWS, there is a way, there is a chance. Should we get remote code execution, then it really doesn't matter what kind of protections are in place, because in AWS, we can just print the environment variables, and everywhere else, we can use curl or some similar command to talk to the metadata APIs and specify all the required headers and essentially bypass all of those security controls. So if we get something impactful like remote code execution, doesn't matter what we're dealing with, we are most likely going to be able to compromise that particular deployment. So with all that said, let's take a look at two instances of serverless deployment. So first up, let's take a look at AWS, and then we're going to take a look at a similar function deployed in Azure. And we're going to attempt to exploit both and see where that leads us. So I'll switch back to my VM here, and let's browse to AWS lambda.victim.cloud. So that's something that we have found from the enumeration we did. So all the subdomains, for example, from crt.sh, we did identify these subdomains. AWS lambda.victim.cloud. And if I just visit this website, it gives me an error message saying missing authentication token. So not sure, how to, not sure what to think. But if I would be approaching this as like a black box, a test, then I would do some form of web content discovery. One of the things I would do is to look for interesting files, again, kind of ignoring that it might be a Lambda function and just looking for interesting things like, I don't know, robots.txt, index.html, index.php, and so on. And I would very likely, sooner or later, hit the /proxy endpoint, which gives me a different error message. And that's very interesting to me as an attacker, right? Because that means I'm triggering some different branch of the code. And in this case, it says missing requirement parameter page. All right, well, Request parameters, well, so I can put that in the URL as a request parameter and say test. Again, gives me a different error message, which is what I like to see. And I was complaining that test is not a valid URI. So kind of making an educated guess here, we are dealing with the proxy endpoint. We've got a parameter called page, and it has to be a URI. So makes sense for me to try to specify URI here, or URL. So let's try to go for google.com. And what happens is I get some HTML back. Let's see the title of the page. Yeah, so the title of the page says Google. So it very likely is reaching out to google.com and pulling down the HTML and presenting it to me. So that's interesting. It looks like, essentially it looks like SSRF. What a surprise. So what can I do with this then? Well, first thing it might pop into your head is, well, metadata APIs, right? So 169.254, 169.254, 169.254. But if I try to do that, it's going to say connection refused. Can't talk to this IP address on this port number. So that's a shame. So there could be like a network restriction in place, or maybe if this indeed is a Lambda function, then by design, it can't talk to the APIs on this IP address. So we can try to mess with this a little bit, maybe HTTP, HTTPS. If I do that, if I change that, it does change the port number here. So it seems that it seems to be sensitive to the protocol I specify. So I could maybe try something like FTP. Nope, invalid protocol FTP. Could try something old school like Gopher or something, old school hacker crazy. Nope, it's not happy either. What about file? That usually allows you to read local files. And if I do that, it actually gives me a different error message, which again, something I like to see. And it's complaining about something, file URL, something, it's unhappy about something. Okay, fair enough. Well, judging by the fact that it talks about Linux, I'm going to take a wild guess and say that this is running on Linux. And in Linux, there's this etc passwd file that's usually reachable. So if I try to read that file, I actually do get a response that looks like a passwd file. So that's a good indication that I have a arbitrary file read vulnerability here in my at my hands. So how do I turn this into something interesting? Well, I could just try to read the source code of the function, maybe just the intellectual property behind that could be interesting. But I'd like to do something a little bit more interesting within the context of the Lambda function. So in Linux, there is this methodology that everything is a file, or everything can be treated as a file. So, for example, on Linux, if you do ls/proc, that's kind of like opening the task manager on Windows. Right? All of these digits, all of these numbers, those are running processes on this machine. And they all have like their own folders and structures within those folders and so on. And this way you can essentially inspect running processes. You would have to guess your process's number. If you don't want to do that, there is a shortcut called self, which always points to the process itself. So I don't have to guess my process ID. I can just use the self trick here to essentially skip that and automatically browse my own process files. So let's go to /proc/self. And if I do that, I get access to all these different properties and attributes of my running process, right? So I can look up things like the command line, essentially the command that started this process. I can look at memory mappings. I can look at the current working directory of the process. I can look at the executable that launched this process. But most interestingly, I can look at the environment file. And yeah, you guessed it, the environment file contains the environment variables. Let's quickly test that locally. So if I read this file from /proc/self, that should provide me with the environment variables of this bash process. And yeah, indeed it does. Like, it just gives me lots and lots of information about this process itself. Okay, so let's try to read this file through the Lambda function then. I'm going to put that file path in the URL here. And I get a different set of results here. AWS Lambda function version latest, session token equals something. That's interesting. Yeah, I get a lot of information here. It's kind of hard to read though. So let's do the same request, but I'm going to do it in terminal. Just to make it a little bit easier to read. Oh, that was a bit too much. Yeah, this is a little bit more readable. Yeah, so this is a variable called Lambda function version. This is the value latest. You can see lots of information like the log stream, the runtime API. Apparently, this is running on Node.js 14. I can see the working directory of the Lambda function. I can see some Node.js related things. I can see the region of deployment, US East 1, so that's interesting. I see lots of interesting things here. There's also the access key ID here, the secret access key, and the session token. So I can even get my hands on some AWS credentials that might come in really handy later on. So I'm going to call that a success. I'm going to call that a great success. Essentially being able to exploit this SSRF vulnerability to read local files. So yeah, I think that's great. Now let's take a look at the other function, at the Azure function here, and see if we can do something similar. So I'm going to browse to Azure function.victim.cloud. And again, I could do some form of content discovery, like just loading up this domain tells me Microsoft Azure, your function app is up and running. So I already know kind of what I'm dealing with, unless this is like a really well orchestrated distraction. But yeah, it looks like yeah, I'm dealing with an Azure function here. If you were to put in some effort and do some content discovery, you probably end up at this point where I can also tell it to go fetch a website and show me the contents, right? But now we are in Azure. And if you remember, Azure requires that special header to be present in order to be able to talk to the metadata API service. So even if I try to talk to it, I'm just going to get an empty page here. If I do this in a terminal to get a little bit more info, yeah, I just keep getting 500s. Like the application is very unhappy about what I'm trying to do. So it's not really communicating back to me. I could try to do the similar trick as last time with the file protocol and try to read local files. I could go for etc passwd, for example, but that doesn't yield anything. So I could try a bunch of these payloads, do this with a relative path, for example, etc passwd. Don't seem to be working. So this being an Azure function, Microsoft kind of sells Microsoft Windows. So maybe it's running on Windows. We can check that. If we go to the Windows folder on the system drive and we look for the win.ini file, this is kind of a dead giveaway. Like if at this location you find something that looks like this, it is very, very likely that you are dealing with something hosted on a Windows system. So yeah, it looks like Azure Function is indeed being hosted on a Microsoft Windows system. So we're not on Linux. That's why we couldn't find etc passwd. But we have been able to find the win.ini file. So yeah, looks interesting. Okay, so yeah, that's pretty much it. We're not able to talk to the metadata APIs because of how it's designed. It protects against this kind of attack. But at the very least, we were able to like list local files, maybe just the intellectual property of whatever code runs this function would be we would consider sufficient as attackers. Maybe that's all we were after. Who knows? It really depends on the situation. But even if you can't achieve SSRF towards metadata APIs, you still might be able to get something out of it, right? So in this case, I've shown you how to read local files, how to orient yourself. This is a Windows system, and so on. So even if you can't ultimately achieve your goal, at least you can get a little bit of info, maybe get your hands on some source code and so on. Okay, so let's now take some time. So I've demoed this for you. So now let's take some time so that you can catch up on all of this. I believe all the commands that I've used have been shared with you. So this is the entry 1 exercise. So feel free to check it out. I'm going to put some time on the clock. And when we come back, we're going to continue. Got a couple more labs to go through today. I can already see like 3 of you completed this. So that's awesome. Yeah, keep it up. But yeah, I'm going to put 10 minutes on the clock. And when we come back, we're going to continue with the labs. So good luck. All right, welcome back. Just answering some of your questions. We have had some questions about how do we discover this, and how do we discover these parameters and so on. Usually, if you can observe the application behave in its sort of natural environment, you might notice that this endpoint is being used. But even if you don't, you can do what's called web content discovery and look for common names here, for example. There are word lists that can help you with this. My favorite one, my favorite repository of word lists like this is called SecLists. This is a really, really good resource. As you can see, it's got like 20,000, actually it's got like 40,000 stars on GitHub. Like this is a fairly popular thing. And it's got a lot of word lists for passwords and usernames. And in this case, mainly the web content discovery. So if I navigate to discovery, web content, I can actually see there are a lot of different essentially text files that contain lots of interesting things. Right? So for example, looking at this PHP fuzz file, this gives me a list of just commonly found PHP scripts, like php.info.php, test1, test2, underscore index, and so on. And you can use this to essentially automatically look for interesting files that are not really linked anywhere, but you can discover them this way. You could also look for parameters. So this is probably my favorite file for parameters. In the, again, web content discovery folder, you've got a file called bird parameter names. And these are some commonly used HTTP or request parameters, essentially. All right, so for example, the proxy parameter is here, so we would have found it this way. The page parameter is here as well. So yeah, lots of interesting things can be found in the SecLists GitHub repository. It's a very, very useful tool for any kind of black box penetration assessment. So yeah, highly recommend this. Okay, so just looking, any other questions? I think that's it. Yeah, I believe that's it. Yeah, okay, cool. All right, do we have, sorry, I'm just trying to orient myself. Yeah, thank you, Manish, for the link. And yeah, as far as the poll goes, we've got people saying that they're not done yet, but we can continue. So we're approaching a coffee break. So what I'd like to do now is I'd like to show you one more lab, and then we're going to take a coffee break. And that can act as like a little buffer. If you're still working on it, you can check it out or come back to it during the break. So in this next lab, I would like us to take a look at platform as a service offering. We're going to be looking at Elastic Beanstalk, and we're also going to be looking at infrastructure as a service offering. Because so far we have done FaaS, right? We have done function as a service, but we haven't looked at infrastructure and platform offerings. So let's take a look. So for the platform as a service offering, we are going to be looking at Elastic Beanstalk. And so Elastic Beanstalk, again, is an AWS offering that is very user-friendly towards developers, because you just click a few buttons and it sets up an environment that can run, for example, PHP or Python or Node.js. And you don't have to mess with it too much. And it essentially sets everything up for you. Now, the problem is that it does so fairly uniformly. And it does break the segregation between control and data planes a little bit, just a little bit, but it turns out like it breaks it enough so that we can do interesting things. So we're essentially going to be looking at something that we have seen in the wild a couple of times. And we're not the only ones. There are other places that have documented and seen this exact chain, essentially. And that is an application that's deployed on Elastic Beanstalk, which is vulnerable to SSRF. Right? So this isn't a Lambda function anymore. This is essentially an EC2 instance. And as such, it does have network access to metadata APIs. And remember, we are in AWS world, so there are no special header requirements unless you go out of your way to enable that. By default, that's not enabled. So as attackers, we might be in a good position here, and we can essentially abuse this SSRF vulnerability to talk to the metadata APIs and extract some information like, extract some information like the AWS account number, the region of deployment, and maybe even some credentials. In Beanstalk, it sets up S3 buckets as well. And it actually allows that Beanstalk deployment, that EC2 instance, to interact with some of the buckets. However, you need to know the precise name of the bucket because you can't just list all the buckets. That's not allowed. But if you know the name, then you can interact with some of those buckets. In this case, we're going to be looking at a case where there is some CI/CD pipeline in place, which essentially might take the source code from that bucket and actually redeploy it. We're gonna see what that looks like in a second. But yeah, this is a fairly common flow. As I said, we're not the only ones that had this in the wild. There are other companies that also noticed this doing assessments. So yeah, if you just Google around Elastic Beanstalk and how it works, you'll find a lot of resources essentially describing this story to you. So let's take a closer look here at the Elastic Beanstalk deployment. And after we're done, I'm going to look at a Azure VM deployment and see what we can do with that one. Okay, so before we begin this, I'm going to have to provide you with some. Actually, sorry, no. We're just going to take a look at this and see where this takes us. All right, so there's a special URL here. You'll notice that it says user XXX in the host name. You're going to have to substitute your username here. So for example, I'm going to be user 410. So you're going to have to substitute your own user account number there because everyone gets their own instance so that we don't have any clashes. No one overwrites anyone else's files and so on. Okay, so I'm going to copy this URL from the slide here and open my virtual machine. Make sure I substitute the digit here. So I'm user 410. And essentially we're dealing with a website here that probably is written in PHP. And it's got this doc request parameter. And whatever document you specify here is going to fetch for you and display. So that's all fine and good, but maybe we can manipulate this somehow. So in this case, it's just fetching a random image from GitHub. Can we make it go fetch, for example, google.com? Well, we get an error message in the browser because it's trying to, judging by the name of the web page, index.php PNG image, it's trying to take this HTML and treat it as an image, which doesn't really make sense. So let's do this in a terminal. I'll say curl, and I'll paste the URL here. And yeah, actually, yeah, we can see that it does indeed fetch the HTML source code for this website. It's redirecting us to www.google.com. Yeah, it seems to be fetching something that I'm gonna go on a limb here and say, yeah, this is google.com with a lot of JavaScript. Okay, so once again, we have an application susceptible to SSRF. Or at least that's what it looks like. So what can we do with this? Well, once again, we can try to talk to the metadata APIs here. And this time it works, right? So this time, again, if you've worked with AWS, you've probably seen this before. It gives us a rundown of the things we can do when we start talking to the metadata APIs. Almost all the time, the thing you want to go for is called latest. So I'll do /latest. And in /latest, we have dynamic, metadata, and user data. All of those are worth exploring. User data is worth exploring because they can provide some sort of bootstrapping scripts. Sometimes people put secrets in user data, which isn't a good idea. That's not what you should be doing, but sometimes it happens regardless. So it's always worth a look. I don't see anything super interesting there, however, so we're going to move on. So the other option we had available was dynamic. So let's check out dynamic. There's just one subfolder here called instance identity. And inside, we've got some documents here, some endpoints here. One of them is called document. If I look at that, it gives me some information about the AWS account and where this instance is deployed and so on. So I can actually see that this EC2 instance belongs to this AWS account. So I can maybe make a little note of this. So account ID is this. It resides in US East 2. So that's good to know as well. I'm going to copy the region. It is a T2 micro, so a fairly low power machine. Not much. It's not very powerful. It's better than nothing, though. There are smaller instances than T2 micro, so it's not that bad. But yeah, interesting. So I get a little bit of information about the instance itself. Next up, we could look at the last option we had available, and that's going to be /latest/metadata, because that's going to have the most information in it. Immediately, as you can see, we've got some information about the image itself, auto-scaling, host name, placement, as in region and data center and so on, public IPv4 address, security groups, and so on. But for us, the juicy bit, the interesting bit is going to be in IAM. Remember, we're hunting for credentials here. So let's go to IAM. And in there we have security credentials. So let's traverse in there as well. And in there we have the AWS Elastic Beanstalk EC2 role, which is interesting. Let's see if we can get to the contents of it. And indeed we can. So actually these look like AWS credentials here. So this is a set of temporary credentials, which is going to expire relatively soon. But no matter, like every single time we hit this endpoint, it's going to generate a new set for us. So we've got the access key ID, secret access key as well, and a token here. So that's already very interesting. So what can we do with this? Well, we could impersonate essentially this deployment. We could do lots of interesting things with this. So let's try to do just that. Yeah, let's try to impersonate this deployment here. So what we're going to do is we're going to set up these credentials. If you've never done that before, we do have a tutorial on how to do that in the Cloud CLI 101 on the training portal here. If you click on that, the very first thing you're going to find is like a little video, but it's actually like you can copy paste from the video, which I think is pretty neat. So you can essentially watch how to set this up. You can pause it at any point, select text, copy and paste, and so on. This is how you can essentially set up your AWS your terminal to use a set of AWS credentials, and you can afterwards verify. You can verify that you have done so correctly. If you execute this command, AWS SDS get caller identity, if it does produce something like this, then you've done everything correctly. If there's an error message, you may want to check how you did things, because there might be a typo somewhere, for example. So let's try to follow this. Let's try to do this exact thing. So I'm just going to prepare my terminal here. So access key ID, that's the shortest bit. That's this thing. That's the thing that starts with Asia. Secret access key is the medium-sized bit that says secret access key. And finally, session token is the longest thing, and you need to be careful to select all of it, excluding the quotes, and paste that. To make this easier for us, I'm also going to specify the region here as per the commands I'll be sharing with you in a second. And now let's try to run AWS SDS get caller identity, and hopefully, if we've done everything correctly, we're going to get something that looks like this. And it looks like I'm now a part of this AWS account here. This is the instance ID, so I'm essentially within the context of like an EC2 instance. And I have assumed role of AWS Elastic Beanstalk EC2 role. And this is the instance. And this is the actual machine that's running. It's very interesting. So this looks recognizable. Maybe if we Google that, let's see, AWS EC2 machine profile Elastic Beanstalk. In the documentation, it actually does walk you through all the things that you can do with this role. So this is the official AWS documentation here, and it walks you through what this role can do. And we're going to get into IAM a little bit more tomorrow, but essentially just skimming through this, it's got something called bucket access here. It seems to be allowing some actions here, like get star, list star, put object, which essentially means writing things. And it's allowing it on a set of resources here, essentially buckets that begin with the word Elastic Beanstalk dash. So we don't have those permissions on everything. We can only do these things on a specific number of buckets, or specific buckets that start with this. And it just so happens that if you read through the documentation of how Beanstalk works internally, you'll find that what it does is when you launch an Elastic Beanstalk deployment, it automatically creates a bucket for you, and it sets up the access to this bucket, just like we can see here on the screen. Because it's an automated thing, it's an automated script, it's an automated program, it's not very creative in the way that it names things. So what it does is it names the bucket Elastic Beanstalk dash, and then it puts in the region of deployment, and then it puts the account number. That's what it does. That's just how it works. So if we can somehow get the account number and the region of deployment, we could reverse engineer the name of the bucket. So even though we can't list all buckets, right, that's not allowed. If we know a name of a bucket that starts with Elastic Beanstalk dash something, 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 then we might be able to interact with that bucket. So as I was saying, sorry about that. AWS is not very, Elastic Beanstalk isn't very creative, right? So it names things in a predictable way. So it starts off with Elastic Beanstalk dash, and then it puts the region. So the region, according to the information we extracted from metadata APIs, US East 2 dash, and then it puts the account number. So hopefully, if we're lucky, this bucket should exist. And indeed it does. Awesome. So we can interact with this bucket, even though we can't interact with just any bucket. But if we know the name and it begins with Elastic Beanstalk, we actually can interact with it. We can read things from it. We can even write things to this bucket, which is going to be very handy. Because I'm going to browse to my to a directory that belongs to me. So user 410 here, that's me. Again, you're going to have to pick your own folder depending on your username. So let's take a look inside CIH EBS user 410. And apparently there's a zip file here. So let's try to download this. So I'm going to say AWS S3, copy. And I'll copy this zip file called index.zip to my local machine. Okay, here we go. Let's take a look inside that file. Oh, I didn't mean to do that. So in this zip file, we have a file called index.php and some text file. Interesting. So yeah, let's unzip this. Let's check out the contents of it. So we have this index.php file here. So it's a PHP script. If there is a get request parameter called doc, it's going to fetch it using curl and display it. It's also going to send a header saying that it's a PNG. So that looks very much like what we were trying to exploit here, right? This is it would tell our browser that this is a PNG image, but it really wasn't. And it was fetching something from the doc parameter, which also aligns with this. So this very, very likely is the source code of this website. So that's interesting. I wonder what would happen if we would backdoor this script. So you can choose to do that. I'm going to create a new file here I'm going to call it backdoor. You can name it whatever you'd like. You should probably call it user, something to make it clear who it belongs to. But I'm lazy, so I'm just going to call it backdoor. And I'm going to paste in a PHP web shell code. I've got this file called backdoor now. Awesome. I'm going to put this file back into the archive, and I'm going to upload it back to S3 where I found it. All right, so let's put the file back. So I'm going to say zip-ur index.zip, and I'm going to specify the new file to put in. Okay. Let's make sure that worked. I'm going to list the files again. Yeah. Okay. Yeah. So I've got a modified zip file now. I've added this new file into it. So let's push this archive back to where I found it. So for that, I'm going to say AWS S3 copy index.zip. And I'm going to copy it to the S3 bucket that I was looking at. Here we go. Okay, so it should be uploaded now. If we're lucky, the AWS code pipeline, which is essentially a CI/CD pipeline, meaning that it can automatically deploy source code, is going to take a look at this file, notice that it has changed, and it might redeploy the source code. This is a fairly standard procedure for CI/CD pipelines. In this case, we're using the AWS native solution, but you could be using any kind of other CI/CD pipeline. This is a very common thing, especially for having like a bleeding edge test build available at all times. Essentially always reflects the newest source code that you have. It might take a second. So I'm going to check on it now. Okay, it's already up there. Awesome. Yeah, so what you can see is like I'm visiting this slash backdoor file that I have put into this zip file, put it back into S3, and then the pipeline kicked in and redeployed that archive. And now I actually have a file here, a script that can help me execute arbitrary commands. All right, so I can do id-a, realize who I am, list the file system. For those of you participating in the CTF, this file is probably very interesting. And the flag.txt file in the root of the file system, that might be very interesting to you. Okay, so that's the EBS exercise. There's one more file we haven't looked at. If you'll recall, in the archive, there was this SIR.txt backup here. I've not looked at that yet. Can take a look. And it looks like a note to someone called Carl, talking about a private SAR repository, and even providing some credentials. Awesome. Well, spoiler alert, this will come in handy tomorrow. We're not going to go into this today, but keep a note of this. We're going to keep this in our back pocket, and we're going to be looking at this tomorrow. So I'm gonna leave this on a cliffhanger for today, and we're going to be looking into that tomorrow. But what we are going to be looking into today is another part of this lab. So this was the Elastic Beanstalk deployment and ways around it, and essentially reconstructing bucket names and pipelines and all sorts of interesting things. But all of this was AWS specific. And I promised you a look at Azure VM. So there's one more bit to this exercise, and that's the Azure VM essentially we're going to be looking at. And we can find it at webapp2. Again, we have found this domain, the subdomain, from Security Trails, if I'm not wrong. So we have identified the subdomain as well. Whoa, didn't mean to do that. So let's go to webapp2.victimware.cloud. And what we have here is a diagnostics page, slightly reminiscent of those home router little boxes that have like a little diagnostics page that allows you to ping a particular IP or do a trace route against some kind of IP address as well. We've got a option box here, list files, test.txt. You can read the file apparently. And there's a option called check connectivity, and that takes a second to load. And it looks like it's pinging Google DNS 3 times. It took about 2 seconds. Okay, fair enough. Interesting. Looking at the URL here, you might notice that it's got a CMD parameter in the URL, and it's actually passing a system level command. If I go to list files, for example, it says ls data. If I go to read text.txt, it says cat data /test.txt. It's clearly passing the command here, which isn't the most secure way of doing things. It may be okay for some use cases, but not for many, I have to say. So messing with this a little bit, running ID, I see that I'm user UID 33, so I'm probably running as a patch or something like that. And I can just execute arbitrary commands, right? So I can do uname-a, for example. That's going to give me some information about the system itself. The host name is webapp2. It's a Linux machine running a fairly old kernel here. It has the Azure in the kernel build. So chances are we are running on Microsoft Azure. This is apparently based on Ubuntu, so that's interesting. Well, if we're running on Azure, maybe we can do the same trick. Maybe we can talk to metadata APIs. Because we have full command execution, right? So no special header requirement is going to stop us because we can to satisfy that requirement, no problem. So let's try to talk to the metadata API. So I'm going to use the curl command, and I'll say curl 169.254.169.254. Actually, I'm going to say HTTP just to avoid any kind of confusion here. And it says that request. So at least it's executing that command, looks like. I'm going to go to /metadata. And it's complaining about a header not being specified. So this is probably what would happen if we exploited an SSRF essentially without the required header. So let's put in the header. So -h metadata true. Now it's complaining about something else. Yeah, this is pretty much the way that it goes with Azure metadata APIs. It tends to always complain about something. They're not the most hacker-friendly API endpoints, but we do provide you with a couple of interesting payloads that you can leverage and use to essentially get your hands on an OAuth token from the actual. Here we go. From the actual instance. So you have to choose the correct API version here. So you can see that quite a few. But following along, hopefully, yeah, here we go. Not sure why it errored out before, but now it's working. Sometimes you just have to refresh. I know it seems pretty low tech, but the more years I spend in IT, the more I believe that's the correct way to resolve most issues. Okay, yeah, so by hitting this special endpoint, /metadata identity OAuth token, we can get the token that this machine uses to talk to the rest of Azure. We could, for example, plug this token into other tools that deal with the API, and we could essentially do interesting things in Azure with this token. And we're definitely going to do that, but we're not going to do that today. I'm going to save that for tomorrow. I just wanted to show you how to do it, essentially, how to traverse the metadata API, how to identify the injection point, and how to deal with the header requirements and so on. Okay, so this is a pretty lengthy exercise, and we've also arrived at a coffee break. So what we're going to do now is I will put on some time for you to look into all of this. So the coffee break, let's say 20 minutes for that. And this is quite a big exercise. So I'll put on extra 15 minutes for that. So that puts us on 35 minutes. Actually, sorry, 45 minutes. Yeah, the coffee break is supposed to be 30. Okay, so 45 minutes, that should give everyone ample time to get a break from my voice because I'm talking a lot. So relax for a second and catch up on those labs because there's a lot to catch up on. But any questions, any problems, any issues with anything, please let us know on Teams. But I think we're going to leave it here for now. So I'll put on this timer, and me and Manish will be available to you on Teams if you have any questions, if you'd like to see something again, if something wasn't clear. But yeah, all the commands as well, I believe, have been shared with you. So you should be able to follow along with all of this. Yeah, entry 2, you can essentially follow up on everything here and have a play with the Elastic Beanstalk deployment, and then take a look at the Azure side as well. And we shall see you in 45 minutes. So good luck. Right, hello and welcome back for the final time today. I can see a lot of you, almost all of you have submitted flags for the exploitation labs. So that's great, that's awesome. We've got about an hour left, and in the hour or so that we have left, I'd like to show you one more lab pertaining to gaining entry. And I'm going to wrap up this module up. Then we're going to wrap up the module, and we will start talking about storage. And depending on how the rest of the day today goes, or any questions that we're going to be answering, we're either going to end on a lab or we're going to save it for tomorrow, depending on what suits you guys. I mean, we're here for you, so I'm not going to force you to do a lab at 6 p.m. we can postpone it for tomorrow, depending on how things will go. Okay, so that was the entry to lab. Essentially, we looked at elastic beanstalk deployment, did some shenanigans with it. We were able to exploit a necessary vulnerability, gain a lot of information. Thanks to the documentation, we knew how Beanstalk works internally. We were able to reverse engineer a bucket name and essentially implant some malicious code in it, which then got deployed through CI/CD pipelines. And we also looked at an Azure VM and achieved remote code execution there too. Okay, so the last lab in this module that I'd like to show you is based on some built-in features that are really good, and you should not be disabling them, essentially. Again, this is based on a scenario where I was doing a architectural review for a company, for a client of ours, and they had this lovely architecture laid out, how things are going to be working, what's going to be exposed, what's going to be internal only, how things are going to be segregated from different parts of the network. And that was all great. And they had a working demo as well. And it turns out that during the lifetime of the demo that they had, they were troubleshooting a problem. And they couldn't find the problem. And they started to suspect, okay, maybe the network policies, maybe the security groups are the problem. So let's disable those. So the AWS security groups are kind of like a firewall, essentially. So by default, nothing gets through, and you need to allow specific communication on a specific port using a specific protocol and so on. You have to whitelist essentially things. And what happened was that they suspected that something has changed, and they thought, for debug purposes, let's disable the firewall temporarily before, until we figure out what the problem that we're having is. So they did that. They found the problem eventually, but they forgot to unroll or roll back, I should say, those changes to the firewall settings. So this screenshot here is from the AWS console. And what this essentially shows you is a security group, which is wide open. So essentially the entire functionality of the quote unquote firewall has been completely disabled because it allows all traffic of any protocol coming to any kind of port number from anywhere through. And that goes both for IPv4 and IPv6, which, that's a pretty vague rule. Like, I'll allow everything from anywhere to anywhere via anything. Essentially completely disabling the protection that a security group brings to the table. And what happened was this caused some sort of middleware layers, caching layers, to be exposed to the internet, right? Because these things were protected via these security groups to not be accessible from anywhere but the front-end servers that would be talking to those cache servers. But actually, because of this wide open network policy, or security group, I should say, the caching servers based on Redis or MongoDB, again, legally distinct, so not Redis, MongoDB, we need to have a similar scenario, but using slightly different components here. Essentially, with basically no authentication required to connect to those servers, which was a big problem. Because again, those were never meant to be publicly accessible, but thanks to some uncoordinated one-off changes, they ended up online. So that's the lab. We're going to be looking at the db.victim.cloud server that we know of, but we haven't really investigated it very much so far. I know some of you have, because I think some of you have submitted the solutions for this already. So we're going to be looking at this db.victim.cloud server and seeing what's up with it and what we can do to interact with it. So the first thing we would do is run a network scan against it. I mean, we can try to load it up in a browser. So I could try to browse to db.victim.cloud, but that doesn't do anything really. It doesn't lead me anywhere. It doesn't take me to the website. It just loads forever, and then it eventually times out. So instead, what we could do is a network scan. As I've already ran this because it takes a little while to run. So instead of you watching me watch this command, I've already ran it. I've run an nmap scan for the top 3,000 most popular services against this db.victim.cloud server. And it has uncovered 2 services listening on the network. One of them is SSH, and that's fairly normal. And the other one is port 27017. And apparently that's MonGod, or MongoD, as I should be saying probably. And that's a lot more interesting, right? Because that's a fairly unusual service. You don't see that too often. And well, it just so happens that we also provided you with a set of client tools required to talk to this Mongo service. Right, so we already have a Mongo client locally. So you could try like the default usernames and passwords. Let's say username admin, password. I don't know, password. I don't know. Let's try change me, something like that. And try to connect to db.victim.cloud. It doesn't work. Authentication failed. I didn't guess correctly, but I do have a word list of a couple of passwords that I could maybe use to try to connect to this database. So let's take a look. I actually have a list of passwords that comes with nmap. I'm going to skip the comments in this file. You can see it has a lot of really horrible passwords, like 1 through 6, 1 through 5, 1 through 9, password, princess, QWERTY, things like that. So not great passwords. So let's actually iterate over this file and use all the passwords in there to try to sign in to the MongoDB instance running on db.victim.cloud. So once again, I've got a handy one-liner here that essentially loops over the file and attempts to log into the MongoDB database. So as we can see, first up, it tries this password 1 through 6. That doesn't work. Then it tries 1 through 5, login failed, 1 through 9, login failed, and so on until we get to password, which gets us in. Yeah, horrible password. Again, this isn't best practice even if this thing is just on the internal network. But then again, if it's only internal and the only servers that are able to access this are the front-end servers just for caching purposes, you could maybe get away with it. But as soon as that those network restrictions are lifted, and this instance becomes available to the public internet, you might be in a lot of trouble. So right here, we have been dropped into the MongoDB shell, and we can essentially issue commands on this remote database server. So I can ask for help, for example. I can look at all the databases that there are, the collections within those databases, and so on. So if I list the databases here, I can see that there are 3 of them. local admin and one that says readme to recover your data. This one is interesting. And it helps me make the point I'm trying to make, because we have been running this instance for a while now. And it just so happens that some black hat hacker is running a script somewhere that is scouring the internet for MongoDB instances, and it's trying like username admin and like top 10 horrible passwords. And that's pretty much the situation we have going on here. So someone found this infrastructure that we have, and they tried to ransom us for money by leaving a ransom node, essentially creating a ransom node here called readme to recover your data. So first up, let's check out this ransom node, okay? So I'm going to switch to this ransom node collection here. DB, what's the syntax? DB readme.find. Well, let's take a look. So this attacker, or a bot, whoever it was, they connected to this database and they've left a ransom node. And they said, all your data is backed up. You must give us Bitcoin to this address. You have 2 days. But they've kind of failed to tell us when they did this. So yeah, I'm not sure when that timer started. And they essentially are threatening to tell GDPR committee about what's going on, that we have some sensitive information here and so on. And that, they're even so nice as to tell us where to get Bitcoin from. Yeah, very nice attackers indeed. You can actually, this is a Bitcoin address, so you can actually Google this. And if you Google it, you'll find that, whoever this is, they're quite persistent. And a lot of people are essentially reporting that someone got into my server. They told me to send money to this address. So there's like 6 people sharing information about this. And unfortunately, some people do end up paying. So we can see here is that this Bitcoin wallet had, can we switch to dollars? Yeah. It has received a couple $100 in ransom money, and it has paid that money to some other, I suppose, more centralized wallet that these attackers have, which is sad because judging by the comments of people saying, I paid, and they didn't give me my data back. So yeah, that's why you should never pay ransom money, because yeah, there's zero guarantee that they're gonna actually help you recover your data. In this instance, the automated attacker, I'm assuming it's an automated attack, right? Because if we look at the databases that we have, and we look at the local one, which actually has some data in it, you can see that the data is still, well, the collection is still there, and the data within is also still there. So they failed to actually encrypt anything or delete things, but they left a ransom note anyway, hoping that, I don't know, we're going to pay up either way. I'm not sure what the end goal was there, but it's an interesting story that kind of organically came up. So that's why we kept the ransom note in there, because this is awesome. well, it's horrible, but in this case, it's an interesting thing to happen. Yeah, I would not want to be on the receiving end of this with actual data loss. But yeah, in our instance, we've not lost any data, but yeah, they left us a ransom note, so that's funny. I don't know. Yeah, essentially, I just wanted to showcase that we've got some sensitive data here, and you can very easily stumble across it. I mean, some random bot on the internet did. So if a random script kiddie bot can find this, then anyone else can. So relying on so having your services listen on all interfaces, and not having any proper authentication or authorization controls in place, and simply relying on the fact that because of a design document, this thing will never be online, but there's no real enforcement of that. That's just not a good position to be in. That's just not a good idea because it only takes one mistake, one debug session that ends in people forgetting to roll back some changes, and you may have a big problem on your hands. Okay, so that's the lab. Feel free to explore. We're going to be sharing all the commands with you, or maybe they're already online. I think so. Yeah, all the commands have been uploaded. So feel free to explore. Feel free to check out all the things that I've shown you. Feel free to Google the Bitcoin address and track the money if you're interested. But yeah, I'm going to put some time on the clock. And if you have any questions, just do let us know. But I'm going to put some time on the clock. And when we come back, I'm going to wrap up this section and I'm going to talk about storage for the rest of the day. And then we're going to call it a day. So I'll see you in 10 minutes. Good luck. And yeah, if you have any questions, just hit us up on Teams. Right, welcome back. That's the last time you're gonna hear me say that today. I need to have like a list of different welcome back messages and prompts, and I need to cycle through that list. But yeah, anyway, sorry about that. Okay, circling back to these slides, wrapping up the entry module here. We're going to be talking a lot more in depth about all of these points on day 4. Day 4 is essentially going to be entirely from the blue team perspective. So don't worry, we're going to revisit all of this. I'll show you some tools that can help you identify these issues, and we'll see how we can fix some of those issues. The main thing I'd like to point out is AWS. Ideally, what you would do is you would only enable the new version of the metadata API and disable the old one. That's easier to say rather than do. Some software still relies on V1, and if you are using software like that, then obviously you can't. There's no benefit to dealing with version 2, because if both of them are active, as that is a possibility. If both of them are active and your application gets attacked, obviously the attacker is going to use version 1 to get around any kind of extra security benefit that version 2 would have. We also had a query coming through about Lambda and the environment variables containing credentials. Again, that's fully in your control as a systems architect. So if you need to assign roles and credentials to a Lambda function, you should make sure they are minimal in nature if you need them at all. And yeah, as I've mentioned, closing off ports on a firewall and just relying on an appliance like that, not a good call. You're treating a symptom and not the root cause, right? So as we've seen with the last lab, the problem was that a purely internal service was simply listening on all network interfaces, including public ones, and it was only prevented from going public through a firewall, which consequently got disabled. So that is also, again, not exactly in line with best practices. Okay, so the last topic of today is going to be storage. I'd like to walk you through some of the theory. We may end on a lab, or we may leave it for tomorrow. I'm going to leave that to you if you want to end on a lab, or if you'd like to look into it tomorrow morning. Both is completely fine. We've designed the training so that it's quite dynamic and we can accommodate these things. So that's going to be completely your call. So before we get to that, however, let's talk about storage. So storage is one of the oldest offerings that AWS has. If you look at AWS history, there are a couple of really, really old school offerings. S3 is one of the oldest ones, alongside things like SQS, which is the simple queue service, essentially a managed MQ server. But yeah, S3 or simple storage service is a really old school offering, and it shows. It does show. If you deal with AWS on any level, and you've dealt with buckets and configuration of buckets, you will know that there are a lot of sort of legacy options and a lot of different ways that overlap a lot when it comes to access control management. And it's a bit of a maze to navigate properly. It does have some historical baggage that it kind of drags along with it. Despite that, however, it is a very cool service. And when it came out, it was kind of revolutionary, because you would pay very little money for storage in the cloud. And you could even run a website, a static website off of an S3 bucket, which is pretty cool. But definitely when S3 was becoming popular, that was a really cool thing. Obviously, storage is very deeply integrated into all the cloud environments that there are. Typically, when you have two offerings, chances are, if you need to exchange data between two offerings, it's probably going to be integrated with, when it comes to AWS, with S3 buckets, right? That's how you're probably going to be exchanging data between multiple things, even internally in a cloud environment. All the big three, well, all the cloud environments really have some kind of storage offerings, storage solutions available, just different names for the same things, really. With Azure, we have Azure Storage. With GCP, we've got Google Cloud Storage. AWS and GCP refer to their sort of directories or storage containers. They refer to them as buckets. Unfortunately, Azure does not. Azure just refers to them as storage accounts and containers. So they're the boring ones. We could have had like one thing that all the cloud providers could have agreed upon, because both AWS and GCP call their containers buckets. But yeah, Azure is not playing ball, unfortunately. But almost got there. So yeah, Azure Storage, however, has some interesting features that we'll explore later on. So yeah, even though they don't call them buckets. And yeah, I should say that storage is one of those services where the bucket names and the container names have to be globally unique. As I say that, I'm going to put a little asterisk next to that, because in the case of Microsoft Azure, it's a little bit different. But when it comes to AWS and GCP, broadly speaking, the bucket names, the container names have to be globally unique, right? So two people can't have a bucket with the same name. I've already talked about that today, but I just wanted to bring that up again because that is quite crucial. Okay, so storage seems pretty simple, right? I mean, there aren't many moving elements. It's literally just data. So what's the problem? Like, how is this insecure? Well, it turns out that just controlling the access to the data can sometimes be a bit troublesome. Broadly speaking, there are three default modes that you can leverage, right? So firstly, you've got the anonymous access option. This essentially means that bucket and the contents of it, are public. Right, so anyone can load that up. They don't have to be logged into AWS or GCP or anywhere. They can just hit that bucket, download data from it. It's all fine. That's one option. You'll see that a lot, for example, with like website assets or images and so on. The other one is called authenticated access, and this one troubles me because the name kind of suggests that there are some access controls that not everyone can gain full access. Well, not full access. Not anyone can gain access to your bucket and to your data. However, authenticated access essentially means, in the case of AWS, anyone with an AWS account can access this bucket. That's what it means. So it's essentially public with a little asterisk saying you need AWS credentials. But AWS credentials are, you can sign up, you can create an account for free, right? It doesn't cost anything. If you don't use any services, that account is free. So there really is very little difference between having a bucket completely publicly accessible and between having it accessible only to people who are logged into AWS, because that really isn't a roadblock, especially not for an attacker. That is a very easy hurdle to overcome. So beware of authenticated access. You should be very careful around that. There are very few use cases where this is handy for anything really. AWS themselves, in the documentation, they say that it's essentially public, but you can more easily track who downloads things from you because they have kind of an identity, because they have to have, for example, an AWS account. But nevertheless, do be aware of this because it sounds a lot more powerful than what it is. It really doesn't protect your data very much at all. And finally, you can have a bucket simply private, meaning that no one outside of your account can access it, or you can share it with just a handful, hand-picked, whitelisted accounts, which makes a lot more sense, especially for sharing data within an organization, for example. You don't want to make that data public, but you do want to share it with other accounts in your organization. Also, there's an important distinction to be made between reading and writing. We should be aware of that, and we should make sure that both are configured properly. So what is the attack surface then? So as I've said, it's literally just access controls. And that sounds silly. That sounds like that's not a lot. That's not a lot of attack surface, but actually it is quite a lot. It's very, well, it used to be really easy to misconfigure things. Again, if you do deal with, for example, AWS on any level, you will know that making a bucket be publicly accessible requires you to click through like 4 different dialogues and warning messages and type yes, confirm, and so on. So it is very difficult to accidentally make something public, but it is still a possibility. And just to drive home the point that everybody gets it wrong sometimes, this is a HackerOne report. We'll do a little bit more. I'll show you a couple more case studies and HackerOne reports as we go through the training. But HackerOne is a bug bounty platform, right? So it's a platform for companies and security researchers to essentially meet and cooperate. The researchers can try to find security-related vulnerabilities in a lot of corporations' infrastructure, and they may get rewarded for it. And this is a HackerOne write-up reported to HackerOne. So kind of a inception moment there. And essentially it was concerning a bucket which was writable for anyone with an AWS account. Right, so maybe the read permissions of that bucket were correctly set. However, the write permissions were quite wide open, essentially allowing anyone with an AWS account to write data to this bucket. And you can see how that could be very easily abused to write a lot of data, maybe incur some or cause HackerOne to incur some storage charges or move data around, maybe put some illicit content in there, post some malware. You can do a lot of bad things when you have a writable bucket like that. Okay, so next up, how do you actually address the bucket? How do you get data out of it from the public side of things? So with AWS S3, there are 2 different ways that you can do this. You can go to s3.amazon.com/your bucket name, or you can take your bucket name and put it in a subdomain. So there are 2 ways of doing that, addressing essentially your buckets. You can choose whichever one you like better. There are some guidelines and best practices, but they're essentially equivalent. That also means, however, that it's very easy to enumerate existing buckets, right? Because you can't create a bucket with the name that someone else already has. So there's built-in functionality for you to enumerate existing buckets. With Amazon S3, so there's a way to essentially have buckets accessible from a particular region. Some people may tell you that's a security feature, but that's not true. It really is not, because you can simply put any region in there, any valid region, and if you don't get it right, you will get an error message that you can't really suppress. And that error message will tell you, sorry, the bucket that you're trying to reach is not available in this region, but it is available in this one. So please use this one. We do have a screenshot showing you that as well. So what we can see here is we're trying to access this victim auth bucket from the region US West 2. And we're getting an error message saying the bucket you're trying to access is not here. You actually need to reach out to US East 2. So not West, but East. So yeah, hardly a security feature when like the website literally tells you what the correct value is. So yeah, no, that's not a security feature. Just wanted to make that clear. Okay, so how do we enumerate buckets? Um, so the, the most amount of tools you're going to find are going to be for AWS, simply because AWS has been around the longest from the big three cloud providers. It is very simple to enumerate buckets, like really, really simple, either by looking up subdomains or by using HTTP to essentially try to get to a bucket this way. So writing a tool like that is very easy. A lot of people have done it. We will be looking at some tools, but not AWS specific. We'll be looking at essentially all-in-one tooling that can help you enumerate all the big three cloud providers. But a tool I'd like to show you is called Cloud Scraper. And I'd also like to show you this search engine called, well, I don't know if it's called Buckets, but it's a search engine by Grey Hat Warfare. It's a very interesting piece of software. Before we get to that, however, some comments on the GCP side of things. So GCP calls their containers buckets, just like AWS does. And you can access them publicly through this URL, where you just put the bucket name at the end right here. Excuse my handwriting. Yeah, slightly better. Yeah, as you can see, we're accessing a bucket called victim public right here, and getting some information about it right here. So once again, GCP, there are tools that can help you enumerate bucket names. You can use a dedicated script. You can use the gsutil suite that comes directly from Google, the official suite of tools, essentially, as we will do in an upcoming exercise. And finally, we have Microsoft Azure. So Microsoft Azure does things a little bit differently. And as you can see, we've got two placeholders here. We've got one in the subdomain called storage name, or storage account name to be more precise. And we have a container in the URL itself. So yeah, Azure behaves a little bit differently. And there isn't just one value. You actually first have to create a storage account itself. And that storage account has to have a globally unique name. So whilst AWS and GCP allow you to set up a bucket and give it a unique name, in Azure, you first set up an account, and that account has a unique name. And within that account, you can have any container that you'd like. Right? So I can set up a container called test. As long as it's within my unique storage account, that's completely fine. So that essentially allows you to get the uniqueness sorted right here, and the containers can have more sort of logical shorthand names like assets or CSS or images and so on. So that can make it a little bit easier to navigate rather than, black hat Asia 2022 cloud 4-day assets. Yeah, that's a mouthful. So the container names within Azure can be quite short because they depend on the storage account itself. There are some oddities as to working with the containers. Essentially, when you want to list the container, you have to provide this magical bit of URL. Essentially, have to tell Azure that, yes, you are aware that you are addressing a container, not a file or not a blob, and what you want to do with it. So yeah, that's a little bit strange. But once you know about it, yeah, it's second nature. It's completely fine. Addressing files directly and blobs, that's fairly intuitive. You literally just access the URL / the container / the file itself. So that's fairly normal. The one oddity here is the listing of things. And also it makes the distinction between the account name and the container makes this a little bit more annoying to enumerate. because first you're going to be enumerating just the storage accounts. And then once you find a couple of storage accounts that you feel like might belong to whoever you're targeting, then within all of them individually, you will have to search for containers. So you're essentially going to be running the search n times for any n storage accounts, which can be a bit cumbersome, but that's just how it is. Now, here's an interesting feature about Azure Storage. So Azure Storage, well, it's quite clever in a sense. It does support more than just files. Like you can have tables, kind of like database tables. You can have queues. You can have essentially weird types of data on Azure Storage that you wouldn't normally think of when you think of directories and files. Tables and queues are a bit weird. So that's one oddity. The other one is the SAS scheme, or the shared access signature. Essentially, this allows you to generate a little special bit of URL magic that if you give to someone, they can append that to their requests, as we can see here. And that will make it so they get a little bit more access than they normally would have. What we can see that this is just, it's a mess. There's a lot of parameters here, a lot of arguments, and it's all kind of readable. So there's not really any confidentiality to this. There is integrity checks. There are integrity checks. As you can see, the very last parameter is called SIG, short for a signature. And that makes sure that we can't tamper with any of these other parameters. I mean, you can try, but then the signature will not match. But there is no confidentiality aspect to this. Like anyone looking at this SAS URL will know what it does, right? So we know when it starts to be applicable, when does it expire, what are the permissions, what are the targets of those permissions, that this token can only be used from this particular IP address over HTTPS and so on. It's a little bit difficult to read if you've never seen it before. So this is a handy table taken from the Microsoft documentation itself that essentially walks you through all the different parameters, whether they're mandatory or optional, and what are the expected values and what are they used for. The main problem with this is people like not knowing what kind of permissions are they going to be needing in future. So they just like list all of them, which isn't the best call of action. It's actually, we can see that happening right here. We can see that this token provides you with read, write, delete, list, append, create, update, process, permissions. Like literally, this allows you to do anything you want with anything within the storage account. So this is vastly overprivileged. This shouldn't exist. This is a bit too much. You shouldn't be distributing tokens like this. So we need to be careful. You need to pick the permissions carefully so that people can't abuse those tokens and cause possibly damage to your environment. We have written a blog post about this. Let me see if I can quickly load it up. Yeah, here we go. We have written a blog post about this some time ago, essentially writing up a story from an assessment that we were doing, where we have discovered a shared access signature, and essentially took it and ran it through a tool called Storage Explorer, if I can find it. Azure Storage Explorer, which is a Microsoft provided tool. And you can essentially use a connection string to connect to it, specify some information there, and you'll get access to the storage account itself. We're actually able to leverage this into getting remote code execution, very similar to the Beanstalk exercise that we have done earlier today. So if you're interested, give that a read, give that a look. But yeah, I think for us, we're going to move on. I'm going to move on from this. Right. This is a really interesting resource. This is a really cool tool. I say it's a cool tool. Depends on which kind of side of the barricade you're standing on, right? If you're on the blue team or if you're on the red team. For a red teamer, this is a really interesting tool. For a blue teamer, it's kind of scary. Essentially, these guys, Grey Hat Warfare, they run kind of like mini Google that is focused on cloud storage. And they index a lot of files from a lot of buckets, Azure blobs, and so on. And they essentially allow you to have full text search capability, just to search through whatever they have indexed, which is very kind of them. But it's kind of, when you start to think about it, what are the legitimate use cases for this? Because I can think of a lot of use cases that are not very legitimate, but would help me with recon, and would be very useful to me in my offensive activities. But yeah, essentially, these people are kind of making money off of your data. That's pretty much what's going on here. Because the catch is, you can search for free, but you can only search a subset of the data that they have collected. Right, so I can only search about a quarter of, maybe a bit less even, but somewhere between a third and a quarter of the data that these people have collected, unless I pay them. So I'll let you formulate your own opinions on that, but nevertheless, it's a very interesting tool. It's a very interesting resource. Next up, there's a tool called Cloud Scraper, which essentially allows you to crawl the web, and it's capable of picking out URLs that look to be related to cloud services. So if you have a website, and on the website there are images, and you load those images directly from S3, Cloud Scraper will notice that, and it will pick out those S3 URLs. Again, really invaluable for doing recon, just getting an idea of what kind of buckets your target is using. Could be very, very useful. And finally, we have a multi-cloud enumeration tool called Cloud Enum. Fairly non-imaginative name, but it is what it is. And this is a really cool tool because you can to use the tool, it's very simple. You literally just feed it a keyword like victim, and it will go off and it will generate all sorts of possible bucket names, storage account names, and so on. And it can enumerate all the big 3 cloud providers, right? So Azure, GCP, and AWS as well. So this is a really cool tool, and we're going to get to use it in the upcoming exercise. However, we're essentially arriving at the end of the day, and this is quite a big lab. So I'm thinking we're going to leave this be for now. We have published the commands, so if you'd like to take a look, feel free to do that. But I'd like to revisit this tomorrow, if that's okay with everyone, because today has been quite theory heavy. Tomorrow's going to be pretty packed with a lot of hands-on labs, so make sure to tune in. But if you'd like to, if you've not had enough just yet, feel free to take a look at the exercise. All the commands have been shared with you. But I think we're going to leave it here for now, because we're just approaching the end of the day. I do not want to hold you past 6 p.m. So I'm quite happy to revisit this tomorrow. So I think that's what we're going to do. We're going to start tomorrow with an exercise, if that's okay with everyone. I think that should be fine. We're essentially going to be looking over some of the tools I've presented, and I'll be showing you how to use them and how you can find out interesting information. That's the plan for tomorrow. Manish has very kindly posted a link to the credentials file. That's the last thing I'm going to leave you with today. In the student pack that you have, there are some extra PDFs related to day 1, 2, 3, and 4. And there are some, essentially those PDFs contain all these write-ups from this website, but in a PDF format. So that's something you can keep after the training as like a handout material. You can keep on hand as a reference. So because this website will go down after the training is over, but the PDFs you get to keep forever. So make sure to keep a hold of those passwords because that's going to come in handy for you to actually be able to open those files in the future. That is pretty much it from us, I believe, for today. So thank you very much for tuning in. Thank you very much for spending the day with us. I hope you found today interesting. I know it's been quite heavy on theory side of things. I promise you tomorrow is going to be a lot more hands-on. Day 3 and 4, we're going to be a lot about containers and Kubernetes and blue teaming. So I think we've got a lot of interesting things coming up. Today was quite theory heavy. Apologies for that. Thank you for sticking with us though. And I wish you a wonderful evening. This is everything from us. So thank you very much for